What is the common point between all those robots? Well, all the robots you see here are or can be powered by ROS. ROS means Robot Operating System. It is something between a middleware and a framework built especially for robotics applications. ROS' goal is to provide a standard for robotic software that developers can use and reuse in any robot. Once you know how to use ROS efficiently, you will be able to set up a new software for a new robot in no time. You first need to master the basics and core functionalities, which you will see in this course. And then, for every new robot you program, you will gain more skills that can apply to other robots. The more you know about ROS, the easiest it will be for you to program and understand the code of any robot. But is that it? No. Another philosophy behind ROS is don't reinvent the wheel. Reinventing the wheel is a very common problem in robotics. People always start building new software that is already existing, and thus they don't have the time to work on really valuable stuff. What if, instead, you could build on a strong software base to directly program high-level functionalities and work on use cases instead of low-level technical stuff that already exists anyway? So this is the why behind ROS. Now, when to use ROS? Maybe you've already started to program robots with an Arduino board or with a custom code on a computer. And what you will quickly experience is that the more sensors, actuators, controllers you add on your application, the more complex it becomes until you reach a point where everything is mixed up and you can't add any code for a new sensor without having a huge headache. ROS is here to help you develop powerful and scalable robotic applications. You can use it whenever you want to create a robot software which needs a lot of communication between its subprograms or has some functionalities that go beyond a very simple use case, etc. So, for a robot that will just open a door with a servo motor when it detects a movement, maybe you don't need ROS. But for a mobile robot, which you want to control with a GPS and a camera, in this case, ROS might really help you. Alright, you've just seen what is the why behind ROS and when to use it. Now, what is ROS? It would be hard to describe exactly what is ROS in about 2 minutes, even an hour. But here are 2 main points that will give you an idea of the big picture. First of all, ROS provides you with a way of separating your code into reusable blocks, along with a set of communication tools to easily communicate between all your subprograms. Let's say that you are programming a robotic arm. You can create a subprogram called node for your camera, another for the motion planning, another one for the hardware driver, another for joystick, and so on. And each of those independent blocks will communicate between each other in a way that is powerful and scalable. The second main point is that ROS provides you with many plug-and-play libraries that will save you a huge amount of time, and most importantly, that will prevent you from reinventing the wheel. If we come back to the robotic arm, imagine how difficult it can be to compute the inverse kinematic for the arm, to plan a trajectory which will make the arm move smoothly and avoid any obstacle on the way. Impossible, you might think, unless you spend 2 years studying mathematics, motion planning, etc. But what if I tell you this? You don't need 2 years. You need maybe 2 days to install a library and figure out how to use it. So you have great communication tools and great libraries. That's not all. ROS is said to be language agnostic. It means that you can program some parts of your application in a programming language and another part in another programming language simply because the communication tools don't rely on a specific language. So in this course, we will not go into all the external libraries that exist for many different robots. We will mostly focus on the ROS basics and core functionalities that will enable you to easily start any robot application powered by ROS using Python and C++. ROS is also open source with an active and growing community. So you can directly see what's going on, you can get help, share your project, and even contribute if you wish to. Alright, with this quick introduction, you should get some ideas about what is ROS, when to use it, and why it is useful. Don't panic though if you don't understand everything right now. The big picture behind ROS is pretty hard to get at the beginning, but after some practice, you will start to get it, and I can guarantee you that you will quickly think that ROS is awesome.